Okay, so in section 2, we're going to continue on with our circle unit. We're looking at arc measures today, and an arc is just a portion of the circle. So it's not looking at the circle in its entirety, but just part of it. So in circles, we have what's called central angles, and a central angle of a circle is an angle whose vertex is the center of the circle, and it just extends to the 2 points on the circle. So for example, if we had this circle and we had center A, this angle here would be a central angle. So the vertex is at that center of the circle and it extends to 2 points on the circle. So the arc is the curved portion of a circle that's bound by a central angle. So if we look at that same central angle here, the arc would be this portion of that circle in between B and C. When we label an arc, we label it with, instead of a line over the two letters, a arc or a curved line. So that would just be like saying the arc BC. So we write BC, we put an arc above it, and that's the label for it. We have 3 different types of arcs. We have minor arcs, major arcs, and semicircles. So a minor arc is going to be an arc that has a degree less than 180 degrees. Major arcs have an arc more than 180 degrees, and semicircles arcs are equal to 180 degrees. So when we're measuring arcs, the measure of a minor arc is just the measure of the central angle. So in this picture down here, we have a central angle ACB that has a measure of 50 degrees. So this 50 degrees is going to be the same measure as this arc AB. So that arc in between those 2 points is also going to be 50 degrees. When we talk about a major arc, so that would be like basically everything else from that minor arc. So from A all the way around to B going the opposite direction, we would do 360 degrees because there's 360 degrees in a circle minus that minor arc, so minus 50, which would give us that 310. Now, when we label a major arc, you have to use 3 points. So we're starting at A, going around to point D, ending at point B, is how they wrote it. Now, I added in this point E because if there's more than one other point that it goes through, it doesn't matter what point you pick. So we could still start at A, go through E, and around to B, and that's going to give you the exact same arc. It's still going to be 310 degrees. It's still going to be the exact same portion of the circle. It's just using point E instead of point D. So that makes no difference at all. But minor arcs, less than 180, major arcs more than 180, semicircles are 180. 360 degrees total in the circle. 2 arcs of the same circle are adjacent arcs when they intersect at exactly 1 point. So if we're looking at this circle down here, AB and BC intersect at point B. So those would be adjacent arcs. Now, when we talk about arc addition, that is literally the exact same thing that we did from the very beginning of geometry, when we were saying angle addition postulate, segment addition postulate, where it's just the 2 pieces added together equal the whole thing. Exact same thing here. So if we need to know the entire value of that major arc ABC, and we know that arc AB is, let's say, 50 degrees, and we know that arc BC is, say, 70 degrees, then to find that whole arc ABC, we can just say Well, measure of arc AB is 50. The measure of arc BC is 70. So that whole arc has to be 120. So you're just adding the two pieces together. Or if you know the whole thing and you need to know one of the smaller ones, you subtract the other smaller one from the whole thing. So it's the exact same thing that we were doing in the beginning of geometry way back in August and September. So in these first 6, we're going to use this same picture to determine if the given arc is major, minor, or a semicircle, and we're going to find the measure of the arc. So what I would do first is I would make sure I know the measure of all of my central angles in the circle first. So I know that this central angle is 120 and I got 60 and I've got 80. So total there has to be 360. So if I subtract those 3 from 360, I'm left with 100 degrees, which is going to be this missing angle. And remember, my arcs are the same as those central angles. So when I'm looking for the arc TQ here, that central angle is 120 degrees, which means that that arc is also 120 degrees. And since it's less than 180, it's a minor arc. So when we look at our next arc, QRT, so we're starting at Q, we're going around through R and stopping at T. So it's all of this here. Now you've got two options. It's everything except the 120. So we could do 360 minus 120, or we can add the three pieces that it is, which would be the 60 degree arc, the 100 degree arc, and the 80 degree arc. Either way, we're going to have 240 degrees, which is more than 180, so it makes it a major arc. When we move on to our next arc, TQR, we start at T, we go around through Q, and we stop at R. So that's the 120 and the 60 degree angles and arcs. So if we add 120 and 60, we get 180 degrees. When it's equal to 180 degrees, that's when it's a semicircle. So I would encourage you to pause this and do these last 3 on your own. See if you can correctly identify the angle measures and the arc measures, and then what kind of arc it is, minor, major, or semicircle. So when we look at number 4, we want QS. Now, QS, there's no way to get from Q to S without going through another point. When it only has 2 letters, that's always the smaller of the two. So to get from Q to S, the smaller distance is to go from Q through R to S. So that's going to be 60 degrees and 100 degrees, which is 160 degrees. So less than 180 makes that a minor arc. TS, from T to S here, we've got 80 degrees, which is going to be a minor arc. And then the last one, from R through S and stopping at T, is going to be our 100 degree arc and our 80 degree arc, which is 180 degrees, which would make it a semicircle. So this theorem 10.3, the congruent circles theorem, just says that 2 circles are congruent if and only if they have the same radius. So if their radius is not the same, they're not congruent at all. So two arcs are congruent arcs if and only if they have the same measure and they are arcs of the same circle or of congruent circles. So it's okay if they're not in the same circle as long as the two circles they're in are congruent to each other. So when we look at theorem 4, the congruent central angles theorem, it says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So if we know that angles CAB and angles DAE are congruent, then we know that arc BC and arc DE are congruent. Okay, so in 7 and 8, we have to determine if the red arcs are congruent, and we have to give our explanation as to why they are or why they aren't. So in number 7, we know that both of those central angles are 145 degrees, which, if arcs are congruent, the angles have to be congruent. And we also know that the radius in 7, or in both of those circles in 7, are congruent. So they've got the tick mark saying that they're congruent to each other. So we have congruent circles, we have congruent angles. So we can say that arc AB is congruent to arc CD. And remember, we know that because we have congruent circles and we have congruent central angles. So when we look at number 8, our central angles are congruent. So we have the congruent central angles. Now we need to know if our circles are congruent. Well, this has a radius of 5. This has a radius of 4. 5 is not congruent to 4, so our circles are not congruent, which means that arc MN is not congruent to arc PQ. They're not congruent circles. And then this last theorem, theorem 5, there's no examples that go with it because hopefully it makes sense to you to just say that all circles are similar. So it doesn't matter what the radii are for the two circles. Those two circles, the radius as a scale factor is only one scale factor. It's the only thing that matters. So they always are similar to each other.